Hello guys, welcome to today's tutorial. So we are discussing on credit risk and credit products, and we'll start from the stochastic interest rate model. So in stochastic interest rate model, this is used because we initially, or in reality, we don't know the interest rates in advance. So we use the stochastic model, and under that we have varying interest rate model, which is the expectation of I is equals to J, while the variance of I is equals to A squared. Then we go to the accumulation of a single investment. So consider a unit investment at time t accumulates under the IID varied interest rate model for the n years per accumulation. For n years is denoted by Sn, as the interest rate that applies in each year is random, that is I. The accumulation Sn will also be random. So we will have that the expectation of Sn is equals to the expectation of 1 plus I1, then 1 plus I2 all the way up to 1 plus In. Then this is equals to the product as I runs from 1 to n, that is 1 plus the expectation of I, where we know that the expectation of I, this one, is equals to, here we have said that the expectation of I is equals to J. So we will have the product as I runs from 1 to n, that is 1 plus J is equals to 1 plus J to power n. This gives, this one gives the expected values of the accumulation under the IID. The variance of Sn is calculated from the standard expression, that is, so the variance of Sn, the variance of Sn, so we know that Vx is equals to expectation of x squared minus the expectation of x all this squared. So we'll have the variance of Sn is equals to the expectation of Sn squared minus Sn all this squared. So this is the expectation of Sn squared is equals to, this is the expectation of 1 plus I I1 squared 1 plus I2 squared times all the way up to 1 plus In squared. So this is equals to the product as I runs from 1 to n, the expectation of 1 plus 2I1 plus II squared. And we know that Vi is equals to A squared. Now the expectation of I is equals to J. So we'll have the product, here we'll have the product as I runs from 1 to n of 1 plus 2 I, that is, now we multiply the expectation with the values inside. So we factor out to the expectation of I plus the expectation of I squared. So this is equals to the product as I runs from 1 to n of 1 plus 2j plus j squared plus s squared. So these two, see, we have said that VSN is equals to ESN squared minus ESN all this squared. So if we want this one, it means that ESN squared is equals to VSN plus E into SN, that is squared. That's, and now see, in our case we have I, so we just into, so E, that is I squared I is equals to V I plus E I all this squared. So this one is equals to S squared plus J squared. Higher. Now from there we get the expectation of Sn squared is equals to 1 plus 2j plus j squared plus s squared, all this to power n. So this is equals to 1 plus j squared plus s squared, all this to power n. I hope you get it, because 1 plus j into 1 plus j, kama kusema 1 into 1 plus j into 1 plus j. So this will be 1 plus j plus j squared, which is equals to 1 plus 2j plus j squared. That is what we have here. Okay, so we continue. So now from there we can say that from there we can have that V Sn squared is equals to 1 plus j squared plus s squared minus 1 plus j, all this to power n, then all this squared, where this one, where that one is the, this one is the expectation of I So we have an example. So number 1, the annual interest rate, the annual interest earned on an investment each year is a collection of IID random variables with mu is equals to 0.05 and standard deviation is equals to 0.15. Calculate the expected value and standard deviation of the accumulation of $10 after 5 years. So first things first, so the solution, we have been told that the annual interest earned on an investment each year is a collection of IID random variables with mu 0.05. So mu is actually the mean or the expected. So mu is the expectation of I, which is equals to j. That means that j is equals to 0.05. And we have been told that the standard deviation, or S squared, is equals to 0.15. That is squared. So calculate the expected value and the standard deviation of the accumulation of $10 after 5 years. So the accumulation of $10 after 5 years, this will be the expected value of 10, but S, N. So N, we know that N is equals to 5 years. 5 years. So this will be the expectation of 10 as 5. So this will be 10 into 1 plus j, all this to power 5. So this will be So this will be 10 into 1 plus 0.05 to power 5. So it will be equals to, when you calculate that, you'll get 12.76. Then the variance VS5 is equals to 10 squared VS5. So this will be 10 squared, all this into 1 plus 0.05 squared plus 0.15 squared, all this to power 5. here it's like we are the formula that we had. Let me first finish. Then 1 plus 0.05 to power 10 okay, so we had a formula that was saying this one. So VSN squared is equals to 1 plus J squared plus squared, this to power n minus 1 plus J to power n, then all this to 2. That's the formula that we are using. So when you compute this, you'll get 4.16. Thank you for your time.